All right, number 2 says, for what values is the rational function f of x equals x squared minus 2x plus 1, all divided by x minus 1 defined? Sketch the graph of this function. All right, and so when looking at where a rational function is defined, we need to watch out for values of x that will make the denominator equal to 0. Okay, so here's our function. And so I'm saying, well, what values of x will make this quantity, x minus 1, equal to 0? And, well, x equals 1 is going to be the problem here. So we could say that f of x is defined for x not equal to 1. So in other words, any other x you plug into your function will be well defined, but at 1 itself, see if I just try to plug in 1 here, the numerator would be 1 minus 2 plus 1, which is actually 0, and the denominator would be 0, and this is just not defined. Okay. So our answer to this first part is here, right? We can plug in anything we want aside from x equals 1. All right. Now, we're next asked to graph the function, and before we go ahead and do that, I'm actually going to go ahead and rewrite our function using some long division. It's going to help us with the graphing part. And so I'll go ahead and take the x minus 1 and divide it into the numerator, x squared minus 2x plus 1. And so x and x squared, that'd be x. And so x times x is x squared, and then x times negative 1 would be minus x. And then subtract. So change signs and add. So that's going to give us negative x, and then carry the 1. Then x into negative x, that's going to be a minus 1. And minus 1 times x is negative x. And minus 1 times minus 1 would be a positive 1. And now subtract, so change signs and add. And we see here that we actually have a remainder of 0. So we can say this, that f of x is equal to, well, on the one hand, its original definition, x squared minus 2x plus 1, all divided by x minus 1. And through this long division, we saw that that's equal to x minus 1, right? The remainder portion is 0. And now for emphasis, I'll go ahead and write in this restriction, okay, that f of x will equal this simplified expression x minus 1, but remember, we have to avoid x equals 1, okay, because of this original definition and the division of 0 that would result if we plugged in 1. Okay, so now what I want to look at is the graph. And the way that this long division process can help us is as follows. Notice that this right here, the x minus 1, is really just describing a line. This is a line with slope m equals 1 and y-intercept b equal to negative 1. So I can go ahead and draw the line here. The y-axis, my intersection with the y-axis is down here at negative 1. And then the slope is 1, so that's just saying if I move over 1, I'm going to go then up 1, over 1, up 1, so on and so forth. So I'm going to be looking at this line here. Okay. But now I do have to take into account this restriction that x is not, cannot equal 1, right? So how is that going to be reflected in this graph? Well, to express the fact that my function f is just equal to values on this line everywhere except at x equals 1, what I'm going to do is just take this point out when x is equal to 1, and I'm going to put in a hole right here. at this one single point. Okay, and this again is because x is not equal to 1 for our allowable inputs here. And as we saw up here, right, f of 1 is just not defined. Okay. So this would be our graph, and that's going to do it for this question here. All right, thanks.